All right, in part 2 here, what we're going to do is we're going to find roots of complex numbers. For instance, if we have the number 3 plus 2i, if we want to be able to take roots like the square root, the cubed root, the fourth root, the fifth root, okay, we can go ahead and we're going to be able to use this formula down here. So if w is a given complex number, let's call this w. Okay, Zn is a complex number to the n to the greater than 2 power. That means I want to find a z that when I raise it to some power n, it's going to be equal to 3 plus 2i. Okay, so that w provides the complex nth root. So these nth roots are given by this equation. Again, don't memorize this equation, but you will be given to it. And notice, remember, when you have roots, you're always going to have 5. You might have double roots and things like that. But in this context, when we're dealing with complex number, it fits around our unit circle really nicely. So just kind of look at this equation to find our different roots. Notice we have a k value. So we're just going to let k be equal to integers, namely things like 0, 1, 2, 3, 4, and so on, depending on the number of roots we are trying to find. So first we'll take the nth root of whatever our r value is, and then we'll go through our equation, n being the roots here. K will start off this being 0, and then it'll follow suit here, and that's going to be the same for our sign. So let's go ahead and look at an example of finding roots of complex numbers. So find the complex fifth roots of -2 square root of 3 plus 2i. So again, to utilize this equation, we got to first put this into polar coordinates. So I'm going to graph it. So I have a -2 square root of 3 real parameter, and I have a 2 parameter over here for my real. So then I need to find my theta and my radius. So my radius is going to be 2 squared plus 2 square roots of 3 squared, which is equal to my r squared. So I get 4 plus 4 times 3, which is 12, which is equal to r squared. And so I get 16 is equal to r squared. So r is equal to 4. To find my theta, I'm going to do tangent of inverse of y over x. So I have 2 over -2 square roots of 3. Pull out my trusty calculator, and I do inverse tangent of 2 over -2 square roots of 3. Close that out. And it's -60 degrees is my principal angle. So that tells me this angle in here is 60 degrees. So here, which is my theta, must be equal to 180 minus 60, which is equal to 120 degrees. All right, so I have my theta. So I'm going to go ahead and write this first in my complex form. So I have 4 cosine of 120 plus I sine of 120 degrees. Now that I have that, I'm going to use this formula to find the fifth root. So, plugging in the equation, I'll do the first one here, but I'm just going to go ahead and show the other ones. You just plug in your unknown. So we're going to have the fifth root of r, which is 4, bracket, cosine. So I'm going to do z is equal to 0. We'll always start with k. This is when k is equal to 0. Then we got to do when k is equal to 1, k is equal to 2, k is equal to 3, and we need to find 5 roots. So that just means we go k is equal to 4th. Because we include 0, we only go up to 4 because we have 5 roots here. So for the first one, we let k equal 0, and we do 5 to the 4th times cosine of theta 120 divided by the roots, so that's divided by 5. And then this all goes, the second part goes to 0 because k is 0. And then I have plus I sine of 120 over 5. Okay. Then from here, the other ones are going to follow suit, and they're going to look something like this. So you have your 5 different roots here. Cosine of 30, then it's 102. And notice that each time here, you're increasing it to 72 degrees. Because from your equation back here, when you did 360 divided by 5, you're just taking that full circle and dividing it into 5 equal parts. And that's 72 degrees. So when you graph these complex numbers, it really ends up just splitting the unit circle into however many equal parts of its roots. So you can see we go, if you think about this as your circle here, this being the center, one root's at 30 degrees, one root's at 102 degrees, one root's at 174, so right before that, one root's at 246, and then one root's at 318, and that's just going to split the things up so that these are all equally split up in our unit circle. And I kind of have this diagram here. You can see this is for a third root. Getting it broke down, I found this image online. But that's how you go ahead and find your roots of complex numbers. Make sure you highlight any questions you have. And be patient with these problems. You're not going to have a whole bunch of them to do, just one to do on an exam or something, because it takes some time to do them. But make sure you have your steps laid out and stay well organized through it. Thank you.